Okay, I'm going to show you how to do a Hess's law problem from the review sheet. In a Hess's law problem, you're always given a desired equation. So this one's given to us as 3 carbons, 4 hydrogens, and C3H8. First thing that sticks out to me is this C3H8. It's right over here. So I'm going to look at my given equations and see if I can find the C3H8. I find it. It's in my first equation, but it's on the wrong side. So I need to flip my first equation. So let's go ahead and do that and rewrite the equation. When you flip that first equation, the products become the reactants and vice versa. So we're just rewriting that. Also, when you flip that equation, the delta H, it was negative and now it's positive. So it becomes positive 2218.8 kilojoules. Okay. Once you've rewritten it, go ahead and cancel it out just so you don't get confused. All right, so now my C3H8 looks good. It's on the correct side, so that's good. All right, let's see what we can find next. I see 3 carbons here, and in my given equation, I only see 1 carbon. So I'm going to have to multiply my second equation by 3. So I get 3 carbons, 3 oxygens, and 3 carbon dioxides. You also have to multiply the delta H by 3. So negative 393.5 times 3 becomes negative 1180.5 kilojoules. Okay, I've rewritten that one, so I'm going to cross it off. The last thing I need to look for is my 4 hydrogens. I see 1 hydrogen in my third equation, but it's on the wrong side and there's only 1 of it. So your third equation, you're going to have to multiply by 4 and flip it. Very exciting stuff here. So I have 1 hydrogen on the right. It now becomes 4 hydrogens on the left. I have a half of oxygen. A half times 4 becomes 2. And then on the right, I'm going to end up with 4 waters. So you have to multiply your delta H by 4 and flip it. That becomes negative 1103.2 kilojoules. Okay, now comes the fun part of canceling everything out. Let's see, let me circle what should not cancel out just to make this a little more obvious. So the circled things should not cancel out. So we have 3 carbon dioxides, cancel out with 3 carbon dioxides. So if they're on opposite sides, they can cancel out. Now we have 5 oxygens here, and we only have 3 here, but we also have 2 here. So add these together, that makes 5, and that cancels out with this 5. And then there you go. You got your desired equation. It matches up. So your last thing, oops, that's a arrow. Your last thing now is to combine these 3 numbers. And then when you do that, you get negative 64.9 kilojoules. And that is our delta H, and that is exothermic. You're all done.